Class, today we are working on Chapter 5, Section 4 in Statistics, specifically dealing with the mean and standard deviation for the binomial distribution. Previously in Chapter 5, Section 2, we talked about finding the mean of a probability distribution and the standard deviation of a probability distribution. I've written the formulas for each one. The mean for a probability distribution is the sum of the random variable x times its probability. And also the standard deviation is the square root of the sum of the random variable x squared times the probability minus the mean squared. So those are fairly, especially the standard deviation, it's fairly lengthy. But when we look at the mean for a binomial distribution, it becomes much simpler. The mean for a binomial distribution is simply the number of trials times the probability of success. And the standard deviation of a binomial distribution is the square root of the number of trials times p, which is the probability of success, times q, which is the probability of failure. Now we're going to look at a problem that deals with a binomial probability situation. A stats student takes a 50-point true-false test. He did not prepare, so the student guessed on each problem. So we can see this idea of two-ness. He's either going to be correct or he's going to be incorrect. Each choice is independent. The chance of success on each problem is the same, and it's consistent all the way through the test. So it meets the binomial probability distribution requirements. So we're going to find the mean of this binomial probability. So I'll say the mean equals n times the probability of success. N is 50. There are 50 questions. The probability of success is 0.5. So I'm expecting to get exactly 25 questions correct, and that should make sense. If I have two options and I have a 50% chance of getting it correct, I would expect to get 25 out of the 50 correct. To find the standard deviation, I'll use the formula. The standard deviation equals the square root of n times p times q. Putting the correct values in, I'll have the square root of 50 times 0.5 times 0.5. Because the probability of success is 0.5, the probability of failure must also be 0.5. And if I multiply that out and take the square root, I get 3.5. The third question says, the student says that they got 35 of the 50 questions correct. So are we likely to believe this person, or do we think that this person might be lying? Well, is it possible that this person got 35 out of 50 correct? Well, yes. It is possible. But is it likely? Well, if I look at our standard deviation and the mean, I see that the mean is 25. Our standard deviation is 3.5. So if I go two standard deviations away from the mean, I'm up at 32. But they said they got 35. That is beyond two standard deviations. So we are saying that is unusual. So the likelihood that the person got 35 out of 50 just by guessing is very unlikely, although it certainly is possible, I suppose. The fourth question says, what is the probability that the student gets exactly 35 questions correct? Well, now we're going back to the last section and saying the probability that x, the random variable, is 35, and we can use the binomial probability formula. Combinations 50, choose 35. 0.5 is the probability of success to the 35 because we have 35 successes. Again, it doesn't matter the order of our correct answers, just that there are 35 correct answers. That's why we need combinations. And we need 15 incorrect. So that's 0.5 to the 15th. If I multiply all of that up, I get 0.002. I could also use the binomial probability formula in my calculator and say 50 comma 0.5 35. And if I did that, I would end up with 0.002. The next question asks the probability that the student gets at least 35 questions correct. So when we say at least, we're saying the probability that our random variable x is greater than or equal to 35. But remember, our calculator thinks from a certain point on down. So I'm going to have to say binomial CDF 50.534, and that results in 0.997. But that gives me the probability of getting 34 correct on down. I'm trying to figure out the probability of getting 35 on up. So I will have to say the probability that x is greater than or equal to 35 is really 1 minus the probability of getting 34 correct on down, which would be 1 minus 0.997, which ends up to be 0.003. So I have a 0.3% chance of getting 35 correct or more if I guess out of 50 questions and getting 35 or more correct. We're going to look at a practice problem now. 10% of American adults are left-handed. A statistics class has 25 students in attendance. What is the mean number of left-handed students in such a class? Well, the mean is n times p, the number of students in this case times the probability of them being left-handed. So I'll take 25 times 0.10 and get 2.5 students. So out of a class of 25, I'm expecting 2.5 students to be left-handed. Find the standard deviation for the number of left-handed students in such a class. The standard deviation is the square root of NPQ, which would be the square root of 25, times P, which is 0.10, and the probability of failure would be 0.90. And if I work that out on my calculator, I get 1.5, so that's the standard deviation. Now, would it be unusual to find 5 students in a class that are left-handed? Well, if I start at 2.5, which is the expected value or the mean, and move 2 standard deviations from that up, I would end up at 4 and then 5.5. So I could see that 5 is within that 2 standard deviations from the mean, so no, it is not unusual to have 5 students in the class that are left-handed. The last problem will assume for the last problem that the probability of developing cancer of the brain or nervous system is 0.00034, very small percent chance. We want to find the mean number of people in groups of 420,095 that can be expected to have cancer. So I'm simply going to take the mean, which is n times p, the total number in my group times its probability, and I end up with 142.8. So out of that 420,095, I'm expecting to find that 42.8 people have brain or cancer or cancer of the nervous system. Now I'm going to say we're going to find the standard deviation. So I say the square root of n times p times q is 420,095 times 0.00034 times 0.99966, and if I work that out, I get 11.9. Well, I'm going to use a 12 as an approximation. Now the question is, in a sample of 420,095 people who use cell phones, 135 of them were found to have cancer. So we're trying to decide if cell phones might be a contributing factor to having brain cancer. Does this imply that there might be a connection between the use of cell phones and cancer? Well, I have 142.8. In my group, I've found that 135 of them have cancer, so that is well within 2 standard deviations from the mean. So my conclusion is that no, this value of 135 is within 2 standard deviations from the mean, so that I cannot conclude that there is any connection. It is not unusual at all. I hope this clarifies this topic of mean and standard deviation using binomial distributions. You should now be ready to work on your assignment in class the next day.